Hello, good afternoon, Trisha, Neil, Christian, and Prince. Before we start, some housekeeping matters. So just another reminder, we will have the second problem set on November 29th. That's on Monday. It will go live on Canvas at 8 a.m. And then the submission is tentatively December 1st, before midnight. But I just realized that tama ba? November 30th is a regular holiday. So I am mulling over postponing the deadline papuntang December 2. Pero pinag-iisipan ko pa, sabihin ko sa Friday kung matutuloy. But prepare for the second problem set. The coverage would be starting from the principle of mathematical induction. We left it out from problem set number 1 until what you discussed in the labs last Monday, which is set operations. So for those who missed the lab classes on Monday, unfortunately you missed a lot because I asked your lab instructors to discuss set operations. Ang na-discuss lang natin last time ay set union, intersection, and set difference. I asked your lab instructors to discuss the complement of a set and the cross product of sets. So if you missed that out, kindly read chapter 2 of volume 2 of the Vortex, or rewatch watch the recording made by your lab instructors. Because today I'll go directly to start chapter 3. Don't worry, this is not yet covered in the upcoming problem set. So ano pa to, sa pangatlong problem set. And I'm looking at the schedule. It looks like we only have 3 weeks and change left before the semester ends. And we still have how many? We still have 3 problem sets to go. So medyo compressed yung mga susunod nating magiging hectic yung susunod nating mga schedule natin sa mga susunod na linggo. Pero don't worry because the problem sets will not be as long as the first problem set kasi yung first problem set kalahati ng SEM yung coverage niya. Pero ngayon siguro 1 to 1.5 weeks lang yung coverage ng mga natitirang problem set. And then I'll give you some instructions for the final project or the final assessment, which will be due during the finals week next year na lang yon. So early January. So dun sa schedule natin ng final exam. Okay? And and lastly, check na lang yung Canvas because I moved some of the deadlines. For instance, worksheet 9, yung iba siguro nagpanic kasi nakita nila November 29th yung deadline. Kababago ko pa lang sa kanya, worksheet number 9 will be due on December 3rd. Tentatively, pwede pa kayong umapila next week. So kung matagal lang kayo sa problem set, just let me know if you want worksheet 9 to be moved. And then worksheet 10 is tentatively for December 8. Tapos hindi ko pa nababago yung worksheet 11 to 13. Okay? All right. And then probably one of the students in the other in the other lecture class asked me about an important part of worksheet number, what was the last worksheet? Worksheet number 8, I think. Because there was a problem there about an intersection of a family of sets. Na-miss out ko pala to sa discussion ng mga notations last time. And the Vortex didn't list also this particular notation. Pero for instance, we consider a family F of sets. So CF isa siyang collection ng mga sets, say A1, A2, A3, hanggang AN. Actually, it could be infinitely many yung laman ni family F, right? But this is a collection of sets. And then we can define in a nice way yung union ng mga lahat ng mga miyembro ni curly F, ng family F. Kasi kung gusto natin kunin yung union na yon, halimbawa tatawagin kong curly U yung union, pwede ko siyang isulat na A1, union A2, union A3, union and so on, hanggang AN, alright? Though sabi nga natin, yung union ay isang binary operation. Ibig sabihin, we can only take the union of two sets, by definition, 2 at a time. So, kailangan nyo munang i-compute yung A1 union A2. Tapos kung ano yung makukuha yung set na sagot dito, yun naman yung i-union natin kay A3. Alright? Tapos kung anong makuha natin dun sa union na yon, this will be a single set on its own. Siya yung i-union ko naman kay A4. So ganun supposedly yung proseso. But thanks to the properties of the union, which was hopefully covered in your lab discussions, ay associative naman yung pagkuha ng union at saka commutative din siya. Pero mas crucial yung associativity kasi we can, the grouping of the sets inside a union doesn't matter. So pwedeng i-group mo together si A1 saka si A2 muna, kunin mo yung union, or you can take the union of A2 and A3 first before taking the union with A1. So posibleng i-regroup nyo siya sa kahit anong paraan. So kaya dito hindi ako masyadong conscious sa paggamit ng grouping symbols, alright? So ganun yung idea. But this might be a very cumbersome notation for the union of all of the sets in curly F, especially if curly F contains infinitely many sets, alright? So mahirap siyang isulat. So we can use several notations. So we can use, say, something similar for the summation notation that you probably have encountered in your previous courses. So we can write it as the union. So use a big cup notation and then put a dummy variable, say AI, all right, where I goes from 1 to n. So basically it says na, okay, kukunin ko lahat ng mga AIs, pero yung I pwede kong palitan ng mga natural numbers starting from 1 until n. Tapos sila yung ipag-union ko. So this notation gives us this long union over here. Pero again, mag-work lang ito kapag ka-discrete yung set. Paano kapag yung collection F natin ng mga sets ay hindi discrete? Ibig sabihin, di siya kayang i-label na A1, A2, A3, A4, and so on. But more on being discrete next time when we talk about the cardinality of sets. Pero kung infinitely many, yung mga laman sige, before yon, pwede natin itong isulat kung ayaw nyo ng merong indices yung union. Pwede nyo siyang isulat na big union lang, tapos isang dummy variable, say A, pero ang condition, instead na I going from 1 to n, kasi hindi ko na nilagyan ng subscript yung mga sets o yung dummy variable dun sa loob ng big union, alright? Sabihin ko na lang ang criteria ko para mapasama dun sa mga pag-unionin ko ay A is an element of curly F, alright? So this means kasama dun sa pagkuha ng union lahat ng mga members ni family curly F. So ibig sabihin, this notation will give us the same set as this one and the same set as this one. Okay? Now, this will also work if you have infinitely many members of curly F. So, posibleng infinitely many yung laman niya. So, ibig sabihin dito, meron ka pang dot, dot, dot. Walang katapusan yung mga pinag-union. So, in this notation, pwedeng gawin yung I going from 1 to infinity or going from 1 to positive infinity. Parehas lang din siya. And then ang kagandahan, itong pangatlong notation is quite more adaptable than the previous notation because still kukunin ko lang lahat ng members ni family F. Sila yung nasa union. So no change necessary rito kasi in-enumerate ko naman ng lahat ng ipag-union ko ay yung mga members lamang ni curly F. Okay? Now, you can replace the union with an intersection, a big cap notation. Parehas lang din yon. Ang ibig sabihin lang, kukunin mo yung intersection ng mga members ni family F. And then, pwede mo ring sabihin ay ganito. Halimbawa, si curly A, tawagin ko siya yung intersection, okay, ng mga sets, say, B intersection B union A, naka-grouping symbol yan. The requirement is that A is a member of the family curly F. So, ibig sabihin naman ng notation na to ay, ang dummy variable ko lamang ay yung nandun sa ilalim ng big cap. Alright? So, ang dummy variable ko si A. So, ang nababago rito sa bawat isang term doon sa union ay yung dummy variable lamang na A. So si B, hindi siya dummy variable, so it's a constant set. So paulit-ulit mo lang isusulat si set B doon sa mga members na pinag-i-intersection natin. So ibig sabihin, si curly A, siya ay intersection ng mga B union A. So yung una, B union A1, alright? Kasi si A1 yung unang nakalistang element ni curly F. Pero hindi naman nagma-matter kung sino yung nauuna kasi commutative naman yung intersection. Alright? Pero you notice here that B is not changed because it's not a dummy variable. The only dummy variable here is A. It will be replaced by members of curly F. Alright? So ito yung unang term dun sa intersection. Then we'll intersect it with the second instance nung dummy variable A, which could be, say, A2. And then intersect this with B union A3 and so on. Okay? Kasi nga si curly F ngayon ay infinitely many na yung laman. Okay? So is that good, guys? Is the notation now clear? I already saw some of you already submitted to worksheet 8. So kudos to you guys who already finished it. Sorry, I forgot to mention it last time, but yeah, I hope this didn't cause any big inconvenience. So if you want to change your answers to worksheet 8 in view of this, just let me know so I can allow you to resubmit another file in Canvas. Okay. All right. So ready na ba tayo for chapter 3? Oh, kumusta pala kayo, guys? Kayo pala yung klase, yung Math 101, ang least ko nakukumusta. Kasi medyo structured masyado yung Math 101 natin. I have two other classes, Math 155 and Math 174. Tapos pag nagbibigay ako ng exercises, lagi ko sila nakukumusta or homework. So, kayo guys, kumusta kayo? How was going back from the reading break? Tumambak ba ang mga requirements ngayong second half ng SEM? Yeah, that's a big problem. I see several smiley reacts there. Okay. Um, Ako personally, nahirapan pa rin. Feeling ko nakabakasyon pa rin kahit ilang linggo na yung nakaraan after ng reading break. Mahirap palang bumalik mula sa isang linggong halos wala kang ginawa. Right? So, but we don't have any choice. We only have several weeks remaining. So let's move forward. Let's see. Okay, chapter 3, relations and functions. Now, kung matatandaan niyo yung video that we played about Nicolas Bourbaki last time, isa sa mga fundamental concepts na winork talaga nila, finormalize nila yung konsepto ng relations and functions. Because relations and functions give us a nice way of finding out the relationship, no pun intended, nung mga elements o mga objects in any mathematical discourse. We can actually bring concepts from algebra, possibly to concepts in geometry or analysis into a one-to-one correspondence para makikita natin yung relation sa kanila or yung interconnectivity between these particular concepts, right? So that's why relations and functions is a very important concept in math. And we will see how relations and functions came about, ano yung mga basic properties nila, and later we will look at more interesting examples of functions and relations. So the goal here is first, overall, gusto muna nating i-define ano yung mga relations, ano yung mga properties ng mga relations, and several ways on how to write relations. And then we will look into a nice example of relations or class of relations called equivalence relations, but I already mentioned it last time. So ngayon natin sila formally i-define, okay? And then in succeeding lessons, pupunta naman natin yung mga functions, okay? But that's the map for chapter 3. Okay, so first definition for the day is the concept of relations. So that's contained in definition 1. So we consider two sets, A and B. Now we say that a relation row from the set A to set B. So the prepositions here are important. So magsisimula dapat kay A, papunta kay B. This relation row is simply a subset of A cross B. Okay, that this row is another set. So isang relation ay isa lamang set. In particular, it is a set of ordered pairs whose first component will come from A and second component will come from B. And that's why I mentioned the ordering or the billing dun sa pagpapangalan ng relation ay importante kasi hopefully you learned in your lab classes that cross product or the Cartesian product is not commutative. A cross B is not necessarily equal to B cross A. So it's very important that when you say row is a relation from A to B, dapat siya ay subset ni A cross B. Okay? And any subset will work. Okay? So ang relation, isa lang siyang set, subset siya ng A cross B. So therefore, ang laman niya ay mga ordered pairs ng first component ay nanggagaling kay A at ang second component nanggagaling kay B. Alright? So if the ordered pair X comma Y is in the relation row, okay, we can write it this way. Alright? Ito yung formal notation para ma-emphasize yung pagiging set ni row at pagiging subset niya ng A cross B. Okay? But another way, if you want to focus more or to emphasize the fact that X is related to Y, so we write it this way, okay? So if there's only one relation in context, you can read this as X is related to Y, okay? Or if there are more than one relation in your discussion, then to distinguish the two relations from each other, you can read this as X is row related to Y, or X is related via row to the element Y. Okay? So notations lang naman siya. Quick example, example 2. Let's consider set A to be the set containing the letters O, E, and V. And the set B is the set containing H comma K. So if you take the cross product, remember the cross product will have cardinality, the number of elements of A times the number of elements of B, simply because kukunin lang natin lahat ng posibleng ordered pairs na first component si A at second component ay manggagaling kay B. So we'll take O, pair it up with the first element of B, say H, hence we have OH. And then first element of A, which is still O, pair it with K, so we'll get the second element. And you do the same thing for E, pair it up with H and K, and also for V. And you can extrapolate the process here. Kaya ganun yung nangyayari. You use the fundamental theorem of counting to prove that the number of elements of A cross B is number of elements of A times number of elements of B. So here we expect 6 members, and true enough, if you are patient enough and you can systematically construct all possible ordered pairs, then you're gonna get this set. Tapos ang usapan, kung gusto mo magkaroon ng relation row mula kay A papunta kay B, pumili ka lang ng isang subset ni A cross B. So take some members of A cross B, put it as your set row. Okay? For instance, dito sa example 2, define niya si row to be this. The ordered pair OH, OK, EK, and VK. All right? And since all of these 4 ordered pairs here are elements of A cross B, therefore row is indeed a subset of A cross B. So we can say that this particular row is a relation from A to B. Okay? Also, curly R in here, the set containing the ordered pairs OH and EH, is also a relation from A to B because its members are both in A cross B. So walang malaking requirement sa pagiging isang relation. Dapat lamang ay subset siya ng A cross B. Okay? So nothing fancy so far. And you can imagine there are a lot of possible combinations for relations. So first pop quiz for today, or I mean recitation. Ilan kaya yung posibleng relations ang pwede kong ma-define kay A cross B? Ito si A cross B. So how many possible relations are there from A to B, where A and B are the sets given on the screen? Yes, Neil Christian?
Sir, ano po, 64 kasi yung 64 po sa 2 raised to 6.
Okay, that's great.
6.
Why 2 to the 6th?
Kasi po, 6 po yung elements ni A cross B, tas sinabi po sa definition na yung subset niya po yung pwedeng maging relation, kaya 2 raised to 6.
Okay, yeah, perfect. Thank you, Neil Christian. So, ganun. Dahil si A cross B ay may 6 na miyembro, sabi natin, sure tayo na may 2 to the 6th subset siya. And bawat isa sa mga subsets na yun ay posibleng maging relation from A to B. So, Neil is right. It's gonna be a total of 64 possible relations. Okay? So, dumarami yung mga relations habang dumarami yung miyembro ni set A at saka ni set B. Which reminds me of a promise I made last week. I mentioned that I'm gonna prove to you guys na ang number of elements ng power set ng isang set ay 2 to the power n, where n is the number of elements of that set via the principle of mathematical induction, but I forgot to do that. So to make up for it, okay lang ba na siya yung isang problem na ilagay ko sa problem set? So so that now you can start trying it out on your own. Tapos pagka nahirapan kayo sa pag-prove niya using PMI, search niyo na sa net para magkaroon kayo ng idea. Pero kailangan pag sinulat niyo siya on paper in your own words. Okay? Yun na lang yung usapan natin. Kasi naglipana na yung mga proofs nung statement na yon sa internet. So just try to write it on your own. Okay? Or if nahirapan talaga kayo, hindi niyo siya kayang magawa on your own, you can take a look at some proofs in the internet, but make sure na pag sinusulat niyo siya, naiintindihan niyo bawat isang line. So para magiging pseudo reading assignment siya if you have difficulties writing your own proof. Okay, and that's fine with me as long as you cite your source and make sure that you understood whatever you wrote in your paper. Okay, so yun. Okay, so nabawasan ng isa yung mga kailangan yung sagutan sa problem set. So paghandaan nyo na yan. Okay? Now, there are some examples here. All right. So ito yung sinabi ko na kanina dun sa unang remark, notations para sa pagiging members ng relation. So since we have from this example, OK, so we can say that O is row related to K. So that is equivalent to saying that O comma K is a member of row. Okay. Now, since there are two relations here, you might want to read, say, O R H. So supposedly, babasahin ko lang yan na O is related to H. Pero dahil meron akong dalawang relations dito sa particular example na to remove any possible confusion, I will be forced to read it as O is curly R related to H. Okay, kasi medyo maraming dalawa yung relations na nandito. Okay? Now, if there's a particular pair that is not in your relation of interest, halimbawa, here we see that the ordered pair E comma K, although it is in A cross B, and actually it's also in row, pero wala naman siya kay curly R. So it is not in curly R. So we say that E is not related to K through the relation curly R. So you can replace, instead of an R, since it doesn't belong to the set curly R, lagyan nyo lang siya ng slash. And this means that E is not R related to K, or you can say that E is not related to K through the relation curly R. Okay, so mga bunch of notations lang para madali yung pagsulat natin later. Okay. Now, here we define two new terms or two more terms. These are the domain and the range of a relation. Okay, so the domain of a relation is simply the set of all first coordinates. So balikan niyo yung relation. Kolektahin niyo lang lahat ng mga nagsilbing first element dun sa or first component ng mga ordered pairs na nandun sa relation. And the set containing all those members, yun yung tinatawag nating domain. So again, the domain is the set of all first coordinates in your relation. And we denote it by the letter D with the subscript, the relation name. So D sub row, this is the domain of the relation row. Okay. And technically, if you want to write it in set builder notation, this is just a set of all x's such that you can find a y that is related to x for some y in B. Okay. Or in other words, this is the set of all x's such that you can find an ordered pair x comma y in the relation row. Okay? And it is easy to see that the domain is a subset of A. Alright? Kasi sila lamang yung mga set ng mga first components. Pero yung mga first components naman ang gagaling lamang dun sa malaking set A. Alright? And similarly, or analogously, if you're going to get the set of second components or second coordinates of ordered pairs in your relation, you will get the range of the relation row, denoted by capital R with the subscript row, yung relation name. Okay? Now, again, technically, this is the set of all y's such that x is related to y for some x in the set A. All right? So, ibig sabihin, kolektahin nyo lang lahat ng mga pangalawang coordinates dun sa relation, yun yung range. And obviously, this is a subset of the set B. Kasi yung mga elements ni set B, sila yung candidates para maging second component doon sa relation kasi yung relation ay subset lamang ni A cross B. Okay. Now, if we'll go back to the relations rho and R that we defined earlier, okay, balikan natin sila. iOS feature ba itong tatlong dots sa ibabaw? Naguguluhan ako sa notability. Laging siya yung napipindot ko instead of the eraser. But anyway, I'll see if I can move that later. All right. So, ano ngayon ang domain ni rho? Can anyone help me out? What's the domain of rho? Aside from Neil Christian, sagot na si Neil. Domain ni rho. Ito si rho. Highlight ko siya. Set of all first components. Yes, Prince. So, itatype yan ni Prince. Jasmine, you want to try what's the range of rho?
Range po is H and K po.
H and K. All right, that's correct. Who's that again? Jasmine, right? So, yeah, kinolekta lang ni Jasmine lahat ng mga second components, H, K, si K na ulit, si K na ulit. So, once ko lang siya i-represent. Okay? And then Prince said on the chat that the domain would be the set O, E, and V. All right? Ang ginawa ni Prince naman, kinolekta niya naman yung mga first components at yun yung nagsisilbing domain ng relation. So O, pero once ko lang isusulat si O, si E, at saka si V. Alright? And notice that the domain and the range are subsets of A and B respectively. So yung relation, ang laman niya ay ordered pairs. Pero yung domain at saka si range, hindi ordered pairs yung laman niya. Yung mga first at saka second components lamang. Right? So you can do this. On the other hand, the domain of the relation curly R is the set containing O and E. So dalawa yung membro niya. Tapos ang range naman ni curly R ay yung singleton na set containing H. Oh, by the way, when we say a singleton, yan yung tawag sa isang set na isa lang yung laman. Okay, it's a singleton. All right, so that's the domain and the range. Okay, what else can we do? All right, so far what we did is a generic abstract example, but of course, relations can also be defined by mathematical formulas. Because by the way, yung mga relations lamang naman ay mga sets lang din naman sila, mga set of ordered pairs. So ibig sabihin, dahil isa siyang set, all right? So yung isang relation row, according to ZF3, all right, or which is the axiom schema for subsets, kaya ko itong isulat as a set of some objects. But in this case, we know that the objects would be ordered pairs, right? So this would be the set of ordered pairs AB, element of A cross B. Ito yung superset dun sa axiom schema, right? Kasi minodify natin yung axiom of abstraction ni Cantor. Sabi natin, may isa pang requirement, dapat meron kang citizenship requirement. So dapat membro ng isang malaking set yung mga elements nitong little set na i-define natin. So ito yung lahat ng mga posibleng maging member nung set row natin o nung relation row. Tapos sabi ng axiom schema, there will exist a formula, okay, or a statement about the possible members that will serve as our criteria kung kailan magiging miyembro siya ni row. So in this case, meron tayong property P about A and B, right? So the axiom schema tells us that we can write the relation row this way. Okay? Tapos, depende na, especially if this is a relation on numbers, posibleng meron tayong formula na ilagay about A and B. Okay? Now, we have illustration 9, but illustration 9 shows us an example of a relation from a set A to itself. All right? So, posible rin yon na si set B mo ay equal sa set A mo. So, we will just be defining a relation from A to A, or in short, a relation from A to itself, or we can also change the proposition. Sa definition 7, sinabi niya na ang isang relation mula kay A papunta sa sarili niya ay pwede nating tawaging isang relation in A. So we change the proposition here from a combination of from and to, ginawa na lang natin siyang in. Okay? And with that said, let's look at example 9. Example 9 gives us an example of a relation row in A. So alam na natin na kung relation siya in A, siya ay isang subset ni A cross A. And true enough, the genus, right? Tawagin natin tong genus. Kung kanino siya member, kung kaninong mas malaking set siya nanggagaling, dahil relation si raw from A to A. So dapat ang mga members niya ay ordered pairs na nanggagaling sa A cross A. So yun yung parang genus dun sa set builder notation. Yung differential niya ay yung property P about X and Y. What should be satisfied by the members X and Y so that they will be members of the order, members of the relation. Sabi rito, we say that X is related to Y if and only if X is greater than or equal to Y. So you can think of this as our property P about X and Y, which will determine the membership to the relation row. Okay? Tapos kung ililista natin sila, ito yung makukuha ko. 1, 1 is in row because this is our X value, this is our Y value. If you plug that into your property P about X and Y, so that inequality will be true. All right. More similarly, 4, 2 is a member of row because 4 is greater than or equal to 2. Okay. But on the other hand, say 1, 3 is not an element of row. All right. This element in row, or you can say that 1 is not related to 3 via the relation row because it doesn't satisfy the property P about X. Remember, ordered pair to. So nagmamatter sino yung gagamitin mong X, sino yung gagamitin mong Y sa formula. So ang X natin dito ay si 1, ang Y natin ay si 3. If I plug those values into this inequality, we'll get 1 greater than or equal to 3, which we know to be false. So ibig sabihin, hindi na-satisfy ni 1, 3 yung differential o yung membership requirement kay row. So hindi related si 1 kay 3. Or the ordered pair 1, 3 doesn't belong to the relation row. Okay? And then it's easy to see that the domain and the range of row are both equal to A. Kasi si 1, si 2, si 3, at saka si 4, nag-serve sila as first components in row. And 1, 2, 3, and 4 also served as second components. So nag-coincide yung domain, yung range, at saka yung set kung saan tayo nag-define ng relation. All right? Everything's good. Puro definition pa lang tayo, no? Siguro kating-kati na kayong mag-prove ng mga statements. Okay, so you can try exercise 10. Exercise 10 defines another relation. This time it's the relation tau. Si tau ay relation pa rin dun sa finite set A. 4 lang naman yung laman niya. So ilan yung posibleng elements ni tau? Or actually hindi pala. never mind. Apat yung elements ni A. Ang diferensya ngayon is that X must be less than or equal to Y. Okay? So you can try it out, list down the elements of tau, find the domain and the range of tau as what what was done in example 9. Let's jump to the more interesting example. This is illustration 11, which will give us a relation with infinitely many members. Okay, so for instance here, we will consider the relation U on the in the set of real numbers. So ibig sabihin si U dapat ay subset ng R cross R. Okay? Kasi nga relation daw siya in R. Then, of course, our genus is that the ordered pairs X comma Y must belong to R cross R. Though since by default ang universal set natin ay R, so hindi na sinulat dito na si X comma Y ay element ng R cross R, but that should be clear in context, so you can drop that. The more important thing here is about the differential. Ang property P about X natin na magdedetermine kung member yung ordered pair X comma Y, yung relation U, ay yung equation X squared plus Y squared equals 1. And then it's easy to find some examples of members of U. For instance, the ordered pair 1 comma 0, then the ordered pair 0 comma 1 are members of the set because you'll have 1 squared plus 0 squared and 0 squared plus 1 squared being both equal to 1. Na-satisfy nila yung property P about X and Y. A more interesting example, may mas high-tech na example, si root 2 over 2, comma root 2 over 2. If you plug in X equals root 2 over 2 as well as yun din pala yung value ni Y, makikita nyo na magiging totoo itong equation na to. So they are both members of the relation U. However, 1 comma 1 is not in U because 1 comma 1 doesn't satisfy the differential. You'll have 1 squared plus 1 squared equals 2, not being equal to 1. So we cannot admit 1 to 1 dun sa relation U. All right. So can you guys give me another members of U? Okay, Prince, go ahead. Some other hands. Okay, Neil Christian, sige. Hindi naman nagtaas yung iba. Okay, madaya si Prince. Ang example ni Prince ay negative 1 comma 0, 0 comma negative 1, negative root 2 over 2, and negative root 2 over 2. That's perfect kasi mag-e-square mo naman sila, so mawawala yung negative sign. Okay, those are also elements of the set. I recognized Neil Christian first, so sige nga, Neil, bigay ka pa ng isang example.
Nasa mga points sa unit circle po, like 1/2 square root of 3 over 2 or square root of 3 over 2, 1. Tapos yung mga negative 1 po.
Okay, perfect. So Neil summarized everything. Hindi niya na tiniran si Bea. So Bea, I'll call on you later na lang. So yeah, Neil is correct. Ito yung mga set of points in the unit circle. So because siguro from analytic geom, you already know that mga points lang yan sa unit circle. Kasi ang equation ng unit circle ay x squared plus y squared equals 1. So any point lying on the circumference of this unit circle will belong to the relation U. And that's the reason why it is called the relation U. Kasi ito yung usual notation, yung double struck U, usual notation para sa unit circle, right? So anything lying on the circumference of the unit circle belongs to the relation, but any point such as say the origin 0, 0 is not on the relation. 1, 1 is not on the relation kasi si 1, 1, nandito si 1, 1. Okay? Nasa labas siya nung circumference ng circle. Okay? So we have seen several examples of relations. The first one, the association between first and second elements might be very abstract. It might be random. It could be an arbitrary pairing as what suits you best, all right? Pero pwede rin naman siyang governed by very strict mathematical requirements, okay? So ito pa yung mga ibang examples ng relations. Equality of numbers. So, ang diferensya natin doon ay x dapat equal kay y. Then, this is another interesting one, membership in a set. So, ibig sabihin, kung ito yung relation ko, hindi pala kailangan na ang relation ay laging object to object. Pwede rin siyang set to set, pwede rin siyang object to set, pwedeng set to object. All right? So, for instance, halimbawa, pwede nating sabihin na kung ito yung membership in a set, right? So, pwede kong sabihin na si 1 ay, tawagin natin yung membership relation as row. I can say that 1 is related to Z. All right? Kasi ang 1 ay element ni set of integers, right? I can say that pi is row related. Pi is related to Q. All right? Kasi kung membership in a set yung requirement, yung unang element, yung first component, dapat ay member nung set dun sa pangalawang component. Okay? So, yun yung nangyayari. So, if this is your scheme, pwede mong tingnan itong relation row to be a relation from the set of real numbers to the power set of the set of real numbers, right? So, ito ay isang relation from the set R. Kasi pwede nating sabihin yung mga first components, kukunin ko lang sa set of real numbers. Ano yung second set? Siya yung power set ni R. Okay. Kasi yung mga second sets na ay yung mga second coordinates natin ay mga sets na subset ni R. So this could be a row, could be looked upon as a relation from R to the power set of R, thus pairing real numbers to a subset of the set of real numbers. So in that token, we can say that, or actually, false pala to. Bakit hindi nyo ako kinall out para doon? So si pi ay hindi related kay Q kasi si pi ay hindi rational number. All right? So dapat ito yung example ko ng hindi siya related. Okay? Probably you can just say 1/2 is related to Q kasi si 1/2 ay rational number. Okay? So, pwedeng napaka-abstract nung relation na i-define nyo. Basta subset lang siya ng isang cross product. Okay? Now, you can also take words, alphabetical order of words. You can say that a word X is related to the word Y if X comes first in alphabetical order. So that means apple will be related to banana. But banana will not be related to apple because banana comes after apple in the alphabetical ordering of words. Okay? Other examples, inclusion. Ito yung pagiging subset. So, kung i-define natin si relation tau, halimbawa, siya yung a relation of inclusion. So, si tau ay relation mula kay, actually, it would be a relation in the power set of R. Kasi ang ipag-prepare ko ngayon ay mga subsets ni R. So, halimbawa, si Z ay tau related kay Q because Z is a subset of Q. All right? And then Z is not tau related to Q kasi hindi, sorry, mali na naman yung example ko, N. Kasi yung set of all integers ay hindi naman subset ng set of natural numbers. But the other way around is true. The set of natural numbers is tau related to the set of integers kasi si n ay subset ng set of all integers. And then what else? The empty set is related to all of the sets in the power set kasi ang empty set ay subset ng kahit anong set. So you can say na ang pinakamaraming kamag-anak ay si empty set because the empty set is related to all sets A that is in the power set of R. Kasi si empty set ay laging subset ng kahit na ano pang set. Okay? Now, there are some more nice properties here. I will reserve congruence modulo for the last few minutes of the class today. But interesting examples, parallelism of lines. You can say that two lines are related if they are parallel to each other. Tapos may symbol na tayo para doon, no? Kung natatandaan nyo from high school geom, ang symbol natin para sa relation of parallelism ay double bars. So you can say that line L is related to line M, okay, via the relation parallelism. And this would be interesting if we are working with Euclidean geometry. Kasi may mga Brandon geometry na lahat ng lines ay parallel sa isa't isa. Meron namang Brandon geometry na lahat ng lines ay hindi parallel sa kahit anong line. So there are no parallel lines or there could be infinitely many parallel lines. So yun yung Riemannian at saka Lobachevskian geometry. Pero sa atin, ang familiar tayo ay Euclidean, where parallelism is a big deal. All right? Of course, you can have longer, shorter, taller, bigger, smaller, etc. And these are examples of parang hindi mo pwedeng pagpalitin yung ordering kasi if A is longer than B, then B cannot be longer than A. So it is possible that A is when A is related to B, then B will not be related to A. Walang symmetry yung relation. Hindi kailangan maging symmetric yung relation. Pwedeng may mga one-sided relationships. Ow. No? So, yun. So, yun yung mga examples niya. And some controversial ones, friends and enemies. Being friends and enemies is another example of relations. But of course, ayaw natin ng kontrobersya. Tingnan natin yung mga mas mathematical na relations like congruence modulo n in the set of integers. So let me focus here for the last few minutes of the class. All right. So we say that A is congruent to B modulo n. Oh, by the way, this is only defined for integers A and B, and then n is a fixed integer. Okay. Then we say A is congruent to B. So ang basa dito ay congruent. So A is congruent to B modulo n if and only if n divides A minus B. Okay? So si A ay congruent kay B modulo n kapag ka yung difference between A and B is divisible by n. So for instance, we can take, say, n is equal to, say, n equals 2. So we can say that 4 is congruent to 2 modulo 2. Because the difference between A and B would be 4 minus 2. That's going to be 2. Pero divisible siya by n, which is 2. So ang n natin dito ay 2. But we say that 5 is not congruent to 5 is not congruent to 4 modulo 2 because the difference between 5 and 4, which is 1, is not divisible by 2. Remember yung divisibility, dapat masulat natin as a multiple ng divisor yung number. But 1 cannot be written as 2 times another integer. Alright? Kasi ang tanging solution nito ay 1/2, pero si 1/2 ay hindi naman integer, so si 2 ay hindi divisor ni 1. Or we say that 2 doesn't divide 1, so that means 5 is not congruent to 4 modulo 2. Okay? But if I reorder this, and if I check is 2 congruent to 4 modulo 2, what do you think, guys? Is 2 congruent to 4 modulo 2 or not? Okay, thank you, Prince. Okay, how about Axel? Yes, Axel, what's her opinion?
Yes po.
Okay, bakit siya congruent?
Pagka 2 minus 4 po, parang divisible pa rin po siya 2 pag minultiply sa negative 1.
Okay, perfect. So, kasi yung 2 minus 4, which is negative 2, ay dinidivide ni 2. Kasi si negative 2, kaya nating masulat as 2 times an integer, namely -1, to become -2. All right? So 2 is congruent to 4 modulo 2. Actually, would you agree that this is symmetric? In other words, kapag ka si A ay congruent kay B, do you agree that B will be congruent to A modulo 2? Or actually congruent to N congruent. So if A is congruent to B modulo N, would you agree that B is congruent to A modulo N? So pagpalitin ko lang yung order ni A at saka ni B. Mukhang tama, no? Kasi yung multiplier na integer na hahanapin natin para dun sa divisibility ay mamumultiply lamang ng -1. And -1 times any integer will give us back another integer. So we'll look more on this. We'll investigate the nice properties of congruence. Pero isa to sa mga fundamental relations na makakasalamuhan nyo if you go to Math 103. Dito iikot yung discussion nyo on the elementary theory of numbers, okay, which is Math 103, which is a nice course. I enjoyed it a lot. Pero we'll build up the foundation by looking at the nice properties of this relation probably next meeting. Okay. So let me just check if I forgot anything. Okay. So I think that's it for today. Just right about time. Do you guys have any questions? Okay, medyo malakas yung loob ko mag-dismiss ngayon ng maaga kasi mukhang maiksi na yung susunod na part. Saka medyo kukulangin tayo sa oras kung mag-start na ako ng definition 18. So let's just reserve it on Friday. And then whatever will not finish with this module will be assigned for your lab instructors to discuss on Monday. Okay? So ganun lang yung gagawin ko para matapos ko yung coverage ng Math 101. All right? But hopefully I'll try to finish the entire module so your lab instructors can start with functions on Monday. Okay? Any questions, guys? I hope kahit mabilisan yung introduction ng relations, you got the idea of what relations are. Medyo limited yung examples, pero if you want more examples, I skip a lot of examples in the work text. Kung nakukulangan pa kayo, you can go to the study guide. Dun sa study guide, meron dyan mga links for additional materials. So, ito, definition of a relation. You can browse 3 supplemental readings here. Yeah, pwede kayong tumingin doon ng mga examples. Okay? All right, so if there are no questions, then thank you guys for coming today. So I hope you'll enjoy your dinner in a while, and let's see each other again on Friday. Bye, guys.
Thank you, sir.